at the laboratory that we are going tomorrow in this class. And our final exam for this class is next Tuesday, right? I believe that is right. Is that right, son? Well, look at my what? Ooh, you want my electromagnet? What? Want my electromagnet? Oh, I may have given it the shooting. I had an electromagnet because I shoot my house. Well, I'm gonna survive. Yeah. Give them your claw. I'm trying to think, claw. Will this work? Aluminium will work, but it has the iron, doesn't it? Yeah. I'll look. Yeah, you should be looking at Craig Fox. Craig Fox has all the nails. All right. Mr. Sue. All right, so if we take a look, here is the neutralization stuff. This is a big part of that test on Tuesday. So if you didn't do these problems, make sure you get the answers down and then work through them. But take a look at those. Basically, you take the molarity of the acid times the volume of the acid divided by the coefficient. That coefficient is in front of the balanced equation. So you need to have a balanced equation to do any of this. When you add an acid and a base together, remember you make water and a salt. You got to make sure that the salt charges cancel out. Phosphate has a -3 charge. Sodium has a +1 charge. So we need 3 of those sodiums in order to balance out that phosphate. Let's see if I can get that a little bit more focused. There we go. A little better. Let's take a look at questions 1, 2, 3, 4, and 5. I'm going to get it to your notes. All right, virtual. No Krishan today.
I'm in the Zoom.
Oh, you're in the Zoom. All right, cool. This is weird. This class doesn't have first and last name. Like I can't switch you guys to first and last name for this class for some reason. So Mara, Nakaya, going once, going twice. No Nakaya. Katie Childs. Henry DeBoyd is a present in person. Lauren Duncan is at home. Seth Eaton is in person. Emily Adder. Josh. Omar. Tori. Olivia is in person. Micah. Micah going once, going twice. Micah. Oh, Micah. All right, cool. Oh, Tony. Tony. Matalucci. Mm. Come on, get him. Yes. Seth wants to know if you're a Zoomer now, Krishan.
Just for the day.
Just for the day. In person forever. Viva in person. All right. So take a look at number 6 as well, please. One of them. Again, note that that is the CB. I'm sorry, yeah, the CB. So make sure that you bring that into play. Backside. I'm gonna drink real quick while you look at 1, 2, and 3. Questions 1, 2, and 3. And number 4. La, la, la. For the last lab of the year. You gonna light stuff on fire? And more. Even more exciting. No. That's what that, yeah, that's kind of it. Questions on 3 and 4. All right. Cool, cool. Let's take a look then. Yeah, whatever. Whatever, kid. All right, so we want to take a look at this lab because we know how hard it is for in-person students to go through this laboratory with you at home just staring at them and not talking to them, right? Is that how it goes? The world according to Seth. Everyone, I'm sorry. Everyone here feel the same on that? Not just everyone, including, not just. Seth is
Everyone at home says they're sorry.
Everyone at home says they're sorry. Not just Namara, everyone.
It's Damara, not Namara.
Namara, not just Namara.
You can't be a hero and apologize for everyone. I need a handwritten apology letter from every single one.
Henry's got visions of grandeur and his imagination is amazing.
Yes.
Not just Namara or Namara, but everyone. That's a nice apology. I don't know if they accept it though. You'll accept it? Seth will accept that. So you can join his group. You want to get here under assignments. You can find that 2 ways, either through the weekly menu or through assignments. And this is the laboratory right here that you want to click on so that you have it. This is something new probably. Those of you at home, one of you in each group, you'll want to click on this and make a copy for your files. So this is the titration curve. And basically, what will happen is, you'll put like numbers here, and then it will create a graph for you. So they are using the pH meters. And basically what this will do is this will create the graph as we go towards and away. They only need to do this once because this will take a little bit more time. They can choose to do it the first time or the last time or middle time, doesn't matter. You guys are doing 3 trials tomorrow. That's the idea. If we don't get done with 3 trials tomorrow, we'll probably drop the second acid and just do the same 3 trials on Thursday. But I would like to see you guys get through all 3. You only need one of these graphs because that takes a long time. So if you're here in person, you may want to pull that off, but you're probably going to want somebody to pull that up at home. That way you can just read to them what it is and you'll like go back and forth very quickly, right? That makes sense? It'll make more sense when you see it. So let's take a look at what it looks like. Stop share. And I'm going to move to speaker view here. Speaker view, speaker view, speaker view. You guys may want to move to either there or there because I'm going to put this right here because actually, yeah, I'm going to put it right here. So this is probably one of the more exciting ones. Seth was getting excited already over. You're going to mix 2 chemicals together. Right? Quite exciting. So the first technique, here I have acid and base, and I'm going to run down through the entire thing. I have these memorized, so I'm going to go ahead and dump these into here. And I'm going to show you guys how this works. pH meters, you guys have used these, right? So we've got all that. Boom, 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 boom. So this is called a burette. This is the cock, and this is the stopcock. So if we take a look, right now this is parallel. That means the cock is open and the liquid will come through. If we turn this so that it's perpendicular, that means that the cock is closed and liquid will not go through. It's the same way on all valves. If you remember these valves in your science class, right now that's perpendicular, so it's off. If I push this so it's parallel, then a gas will flow out, right? Anything in science that has a tip like this and that has something that flows through it, that's a cock, that's a cock. So just keep that in mind. This is the acid. We don't know the concentration of the acid. So I'm going to make sure that the cock is closed, and then I'm going to take and watch this, guys. You might want to watch here. I'm going to take and put my thumb there, and I'm going to pour just a little bit in, about 2 milliliters. And what I'm going to do with that is I'm going to move that around and basically flush this tube out, right? And basically this is going to get rid of any impurities and replace it with the acid I'm using, right? I'm going to open that up and let that come out, maybe. There we go. All right, so this is pretty clean now. Now I can close that and then fill it up as much as I need to for the trials. I probably need at least 11 milliliters to 12 milliliters for the trial, and that's a good trial. So you may want to make sure that you have 15 milliliters in there. This is called a butterfly clamp. So if I just grab those and squeeze those, that's going to drop straight down and break. You don't want that to happen. If you're going to squeeze these, you want to make sure you have a hold of this, and then that can release it. Whenever you put that back in, push up and down on these 2 things, and that will make sure this doesn't slide. Now I'm going to do the same thing to the base that I did to the acid. If I don't close this, then I'm going to pour it on the person that's behind me, or if I go like this, maybe even my own pants, right? So I'm going to make sure that's closed. We're going to start with 2 milliliters again. And I'm going to flush this out. And then I'm going to dump it. Right. So now that's cleaned. And we're going to open this up and we're going to put that in there again. You guys remember this is probably the harder parts, right? To make sure that you watch this so you know exactly what you're doing tomorrow, because you're gonna have to make these same movements. Yeah. Huh?
What?
Yeah.
Yeah.
Yeah. So then I'm going to fill up the base. Now, if you'll notice on your acid base data sheet, you want to follow along with the procedure while I go through this. You'll notice there's a nice data sheet right here. You may want to do this practice one with me today. So I'm going to get the initial volumes of each of these. Actually took off my glasses and put my contacts in. So let's see if I can do this. All right, we are at 28.5. Let me just get a little bit out so I can get it right to that 0.5 line. I need to go out some anyway because I need to have the cock filled. So we can see that filling up. Let's see where I'm at right now. All right, so I'm gonna let a little bit more out and I'm gonna go right on 29.0, just so I feel comfortable, 29.00. So right there where it says initial, I'm gonna write 29.00. You guys write that for me. The base, same thing. Right now, the cock does not have liquid in there, so it's not gonna be a good reading. And I need more base. I just realized that. You always want to make sure you're going to have enough of the chemicals to start off with. Again, this is one technique if you're tall. If you're not tall, don't try this bad boy. All right, that should be enough. So again, I want to put something behind here so I can see the reading. I'm going to turn it so that the numbers are facing me. And I need to have that filled up. So that's my first technique, is to make sure that that has something in it. That puts me right about 18. I'm going to go down to 18.0. So 18.00 for the initial volume of the base. We comfortable so far? Have I done anything extraordinarily difficult? No. Our next technique is to get 10 milliliters of the acid. So I'm at 29, so where will I go down to? I will go down to 39. This measures how much you've dispensed, not how much is in there. So 29 down to 39. I'm going to stop right there. I'm not going to take that final measurement because I may need to add some acid later if I'm not happy with the results or the blueness that I've got. I'm going to add this indicator. If I don't add this indicator, it will never change colors. So 1, 2, 3, 4. That's bromothymol blue. Take a look. What color is it? Yellow. It turns blue whenever the pH is 7. This is HCl. So this is a strong acid. We're using sodium hydroxide, which is a strong base. They will equalize each other out at pH 7. Now I'm going to take a look at my pH here. I'm going to take my reader and I'm going to put it in here, mix it around a little bit so that I can find the pH of this chemical. So the pH here is 1.54. So right away, I could get, since I know the pH, I could take the antilog of the negative pH. And that means that I got a 0.028 or 0.288 molar concentration of HCl. That's one way I could get the concentration. I want to test that through titration now. So by adding the base, I will neutralize the acid and we will get a blue color. But for one of my trials, I want to make sure that I add 1 milliliter of NaOH at a time. So we'll go down to 1 milliliter. And then we will take the reading. what should be happening as I add base? pH should be going up or down as I add base? Up. So that's what I'm seeing here. And somebody at home would be typing that into the graph, right? Into the data sheet table. So then we add another milliliter. I mix. I tell somebody at home now it's at 1.50. And each time it should be going up. Add another milliliter of the base. Somebody at home also at this time could tell me how many milliliters I should need to add by using the concentration based off of the pH and the 10 milliliters I used and using that Malva-Ka formula. Now I'm at 1.56. Another milliliter. Now I'm at 1.67. I'm starting to see some blue, so I'm going to slow down to half a milliliter. The reason for this is I want to get a nice curve on there. Take a look, 1.89. Half a milliliter. $2.27. Half a milliliter. Actually, I'm going to do drop by drop here for this one. Because look at that. I just reached it. What do you think the pH is going to be about right now? What pH did I say neutralization should occur? 7. So right here, right now, we're at 5.32. So I could add another drop. Let's see. Oh, more than a drop there. My unsteady hands. Now we're at 7.91. So you can see right there, if I would have added like one drop, we would have been closer to the 7. But that's the deal. Once it changes pretty quick. On the one that you are making the graph for, you want to keep adding until you don't see a change in the pH again. So adding 1 milliliter by 1 milliliter, and eventually that will level off. Now I'm at 11.60. Add another milliliter. Now I'm at 12.0. Another milliliter. Now I'm at 12.04. So that would be good enough. I could stop there. Let me show you what type of graph you're going to get from that. We'll call this a titration curve. Because it stayed constant. It was 12 and then it was like 12.04. It didn't go up much, right? So let's take a look at what your graph should look like at the end. Did I close the visualizer? There it is. Let's take a look. Here is data from a trial that I did, not the acid that you guys are using, but what you should see is a big curve right here, and then it curves back out and then becomes constant again. So that's what we want to see. This is the volume. Whenever you look at that line at 7, that should be the volume that titrated it. And then you can take that data that you collected from here, and then you can put this in. This is the Va, this is the Vub. We know the molarity of the base, it's 0.130. We know the formulas for sodium hydroxide plus HCl. Well, we should be able to figure that out. And then we can use the Ma Va of a Ka equals Ma Va of a Kub. Well, that's the laboratory, and that's what our goal is for tomorrow. And then Thursday, we want to do a second acid. Thursday, the acid is a weak acid. Whenever we take a weak acid, remember, it becomes a conjugate base. So instead of the pH being 7 whenever you neutralize a weak acid, the pH creates that weak base, which makes the pH go up from 7. So we would also need to use a different indicator. That indicator right there changes right at 7. So it's good for that. But if we're more basic, we need to have an indicator that will change then. Homework for up to, I don't have class with you guys on Friday, but on Tuesday, your homework up to Tuesday is to finish that laboratory that we're doing tomorrow, and this right here is the review for the acid-base test. I'll try to put another one maybe on Canvas or something like that. Any questions? All right, then tomorrow we lab. Final volume, you subtract it. You want me to get it real quick? All right, I'm gonna get those final volumes for So the final volume of the acid is the same. It's 39.00. Final volume of the base is 26.99. Yeah, I added 10 milliliters of the acid and then so many milliliters of the base. I don't know, you'd have to do the subtraction. Boom, boom. You subtract the two to find the actual volumes. Yep. The final minus initial. That's what I got for today, guys. If you have questions, by all means, stick around. Otherwise, get out of here.
Thanks.
What's up?
For the titration graph, it says we need access.
Oh yeah. Are you guys logged into your MSDWT account on Google?
Yeah.
You sure?
Mhm.
Because I've got it to share with people in MSDWT. Try now. That
Yeah,
did that change it? Yeah, you can get it now. Okay, good.
Thank you.
Thank you for letting me know. Anybody else?